Hello everyone, in this tutorial series, our goal is to create the traffic system. And in the first tutorial, we will create the vehicle AI that can follow the spline. First, we open Unreal Engine. I use Unreal Engine 5.4. Go to Game, Third Person, and choose the location that you want your project to locate. And name this to traffic tutorial and create. Go to Unreal Engine Marketplace. Search for city sample and we use this city sample vehicles. Open in launcher. We can add to project after you download it. And show all project. Search for traffic tutorial, this one. And change this to Unreal Engine 5.3. Add to project. After you add to the project, you can close this. And you can see there is another folder name is City Sample Vehicles. And go to Map, open City Sample Vehicle, enable this plugin. And we can go to Project Setting, change this map to default map, City Sample Vehicle map. And now we can restart. We have a warning. Reflection captures need to be rebuilt. We can build these reflection captures. And we don't have any warning. Let's play. We can drive this first vehicle. And for other vehicle, we can click the number that possess that vehicle. Example number 4, this vehicle. We can go to level blueprint, event, and in the begin play, I don't want to possess the vehicle. So disconnect this, compare. Now when we play, we possess this third person character. Go to content and create a new folder. Name this folder is traffic. Open this and create a new blueprint actor. BP Spline Road. And go to City Sample Vehicle, this blueprint, BP Vehicle, create child blueprint. And name this to BP Vehicle AI. Move this to traffic folder. We can open BP Spline Road and add a new spline component to this spline component. And compile, save. For this floor, we want to change this to only one material. and make this larger. Delete floor from floor 2 to floor 160. Delete. And we left only one floor. Set the scale to 100x and 100y. And we want to change the material. Search for MI prototype gray. Use this material. Next, we add this spline rod in the scene. And we can click on this point of the spline and move it to create the road for the vehicle. We can right click, add spline point here. Right click, duplicate spline point, move it, and set close loop to true to close this spline. Add this BPV called AI to the scene. But when we hit play, we can see that the spline does not appear in game mode. So we want to debug this. Go to level blueprint, call execute console command, and the command is show flag dot splines 1. You can use this command, and when we play, we can see this spline appear. We can close this level blueprint and open BPV called AI. Search for auto, and this auto process AI, we want to process it when we place invert or spawn. Go to event graph. We want to get the spline from the scene. So get all actor of class. BP spline road. And we need to find the nearest spline. Add another function. Name is find nearest spline. Input is Spline Actors and BP Spline Road. Object reference. Change this to array. Add local variable. Name is distance. Change this to float. And set this distance to 0. Call for each loop. And if the array index is the first one, equal to 0, we get spline component find location closest to world location, set coordinate to world, get actor location, connect to world location, and find the distance between this spline location and this actor location. If it is the first spline, we set this distance. And add local variable is nearest spline. Name this variable is BP spline road. Set this. This array element is the nearest spline. Compare this distance less than distance. We compare the next spline with the first distance of the spline. If we don't set this first, we don't have anything to compare. Create a branch, and when it falls for other index, we compare this. If it's less than the distance of the last one, we need to set this to distance and set it to nearest spline. When we complete the loop, we return and get nearest spline. And we return this spline actor. Save. Go to event graph. Call find nearest spline from all the actor that we get. And we promote this to variable. This name is default spline. And duplicate this. Name is Spline Actor. And this Spline Actor, we set this default spline. Because we want to store this default spline to use it later. And add another variable is default max speed. And set it to float. Another one is max speed. This is the max speed of the vehicle. And set this max speed to 60. Get max speed and set default max speed. Now we have the spline for our vehicle AI. Next, we need to figure out how to control this vehicle. Add another function. Name this to calculate steering input. And input is spline. And BP spline road, variable, and single. First, we get spline component. Because this variable is spline actor, so we need to get the spline component inside this. And find tangent closest to world location. This is the vector. Get actor location. Connect to world location. And set this coordinate space to world. Normalize this vector to get the unit vector. And multiply. Convert this to float. Get vehicle movement component. Get forward speed mph, mile per hour. We use this because it's less number than the first one. Get forward speed. It's easy to understand the speed of the vehicle. We multiply this by 10 and add it with 250 and connect to this. And this actor location, add it with this vector. We change the location depending on the speed of the vehicle. And this spline we call find location closest to world location. And in world coordinate space, this world location. Add another variable. Name this to offset tangent location. Change this to vector. Set to this. And add another variable. Name is debug steering. Change this to Boolean. We can compile and set this debug steering to true. And create a branch. We get actor location. Find look at rotation. And this offset tangent location is the target. Find delta rotator from this rotation to the actor rotation. We want to find how much the difference between the actor rotation and this forward tangent rotation. And split this. If it's true, we call draw debug sphere. And we can use this offset tangent location at the center. Radius is 25. And the color, change it to red. Duration is 0 because we will call this function every tick. And set this thickness to 1. And draw debug arrow. This line start is actor location. And this offset tangent location is line 8. Arrow size is 1. Color red again. Thickness is 1. Set it to 10 to make this thicker. add variable is your data and set this to float. Connect this your to this your data and map this float, map range claim minus 15, 15, minus 1 and 1. Because the input of steering only receive the value from minus 1 to 1. Minus 1 is turn left and 1 is turn right. Return and connect this to return. Go to event graph. We can delete this actor begin overlap. Event tick. Get Spline Actor called is valid to avoid the error if there are any Spline Actor here. And create a sequence called calculate steering input. Get Spline Actor next to this and get vehicle movement component. Set steering input and use this return value as steering input. Next, we want to control the throttle of the vehicle. We get your data and call absolute. Map range claim. The range is 30 and 5. We choose this 30 because when we open this vehicle movement component and this wheel, open this front wheel, we can see the make wheel spin rotation is 30. So we can use this 30, duplicate this max speed, name is min speed. Compile, set this to 5, min speed. Get min speed next to range A and max speed to range B. And we add another variable is target speed. And set this target speed. The difference of the yaw rotation is large. We slow down this vehicle, and if the difference between yaw rotation is small, we speed up this vehicle. Get vehicle movement component, get forward speed mph, and less than target speed. Create a branch. Get vehicle movement component. Set throttle input. Set this to 1 and set this to -1. We want to maintain the target speed, so if it's less than the target speed, we add the throttle. Can move this down Go to vehicle movement component and this wheel front L. We change this to wheel front turn L. The bolt name, because this wheel front L and wheel front O cannot turn. Wheel front turn O. Compile and save. Let's play. You can see this vehicle moving along this line. And it turns. But the vehicle seems moving very fast. We need to create the brake system for the vehicle so it can slow down to turn. Go to BP vehicle AI. Add another function. Is calculate brake input. At input is spline. Origin location. Set to vector. This function is similar to the last one, calculate steering input, but the point that is our target point is further than the last one. So the vehicle can detect the change of the spline to slow down before they steer the vehicle. Get spline. Find tangent closest to world location. Get origin location next to world location. Choose world space coordinate. Normalize this vector. Multiply. Convert to float. Get vehicle movement component. Get forward speed mph. Claim this value. Claim float. And the min is 1. Make is this speed, because we don't want this to be 0. And multiply with 50. Connect to this. And this origin location. Add. From this line, we call find location closest to world location. And this world location, change this to world coordinate. Add boolean. Name this to debug brake. Set this to boolean. And get brake. Debug brake. Create a branch. Connect it to here. And we get actor location. Find look at rotation. This closest to world location. And call delta rotator. Get actor rotation. Next, we split this rotator and call absolute. Add with your data from calculate steering input, call absolute. We want to make this less effective for the brake. So divide this by 4. Need to add call map range clamp. The range is 15, 35, and out range 0 and 1. You can adjust this value to the value that you get the good result from it. Add local variable brake input. Change this variable type to float and set this variable brake input. We need to call debug first. Copy this and paste this. This is the center and the start is actor location to this location. Change the color to green and this one to green. And set this brake input. And if it falls, we still continue. Get vehicle movement component. Get forward speed mph. Less or equal to 5. Create a branch. We can change this file to min speed, less or equal to min speed. If it's true, we set this set brake input variable to 0. Because we don't want the vehicle to stop and stand still, so we need to stop this brake and call return. Next for to return and get this brake input. Next to return. Name this to return value. I'll go to event graph. Get Spline Actor. Call calculate brake input. And get offset tangent location as the origin location. Get vehicle movement component. Set brake input to this return value. Comment on this. Select all and press C. Name this is steering and brake. Press C. And this one is throttle. Move here. And next we need to make the category for this. This max speed. Category name is speed control. And this min speed. change to speed control. This debug. Name the category is debug control. And this one, debug brake to debug control. Debug brake, set it to true if you want to debug. And this speed control, we can change it to any speed that you like. This max speed and the min speed of the vehicle. Let's play again. You can see the vehicle is slowing down. You can adjust the value. This calculate steering input. Change this to 5. If you want to make the vehicle move from the left to right, you can adjust this point. Change this to the right and change this back to the left. If the vehicle moving too fast, we can change this max speed to 40. We need to change the center of mass location and the mass of the vehicle. This is the end of our first part of the tutorial. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. See you in the next tutorial.